Let's move to the question number 6. The curve has parametric equation x is equal to tangent theta and y is equal to sine theta minus 2 sine cube theta, where theta is less than pi by 2 and greater than 0. Show that dy over dx is equal to 6 cos to the power of 5 minus 5 cos cube theta. Okay, we have the x which is tangent of theta, and we have the y which is sine of theta minus 2 sine cube of theta, and we need to find the dy over dx. We can find dy over dx by using the chain rule, which is dy over d theta over dx. When theta will be cancelled out, we will have dy over dx. So we can find dy over theta by applying derivative to the y with respect to theta, and we can find derivative of x with respect to theta by taking differentiation of the x with respect to theta. So first we find dy over d theta, and this one is equal to derivative of y, which is sine of theta minus 2 sine cube of theta with respect to d theta. We know that derivative of sine is cos of theta minus 2. Derivative of sine cube theta is 3 sine square of theta, and derivative of sine theta with respect to theta. Further solving, we will have dy over d theta is equal to cos of theta minus 6 sine square theta, and derivative of sine theta is cos of theta. So this one is equal to the cos of theta minus 6 sine square theta cos of theta. This is the dy over d theta. We have calculated the dy over d theta. We need to find the dx over d theta, and x is equal to tangent of theta. Okay, so dx over d theta is equal to the derivative of tangent with respect to d theta, and this one is equal to secant square theta. Okay, which is equal to the 1 over cos of square theta, because secant theta is equal to 1 over tan cos theta. We can say that dx over d theta is equal to 1 over cos of square theta. Now we have the dx over d theta and dy over d theta. Plugging in this equation, we will have dy over d theta. Okay, this equation can be written as dy over d theta divide and dx over d theta. Okay, dy over dx is equal to dy with respect to d theta over dx over d theta. Plugging dy over dx is cos of theta minus 6 sine square of theta cos of theta over dx over d theta is 1 over cos of square theta. As we know that sine square theta is equal to 1 minus cos of square theta. So plugging this, we will have dy over dx is equal to cos of theta minus 6 sine square theta 1 minus cos square theta, then cos of theta over 1 over cos of square theta. Okay, further solving, we will have cos of theta negative 6 minus 6 cos square theta, then cos of theta over 1 over cos of square theta. So dy over dx is equal to cos of square theta time cos of theta minus 6 cos of theta positive 6 cos of cube theta. Okay, dy over dx cos square theta, cos theta minus 6 cos theta negative 5 cos of theta plus 6 cos cube of theta. So after multiplying, we will have negative 5 cos of cube of theta plus 6 cos of to the power of 5 of theta. So dy over dx is equal to 6 cos of 5 to the power of 5 theta minus 5 cos of cube of theta. Okay, let's move to the part B. Find the equation of the normal to the curve at the point where it crosses the x-axis. Give your answer in the form of y is equal to mx plus c, where m and c are the exact constants. We need to find the equation of the normal to the curve at the point where it crosses the x-axis. If the curve crosses the x-axis, it means its y coordinate is 0. So we have the curve equation in the form of theta, which is y is equal to sine of theta minus 2 sine of cube theta, and in this case y coordinate is 0, so we find the value of theta, and so 0 is equal to sine of theta minus 2 sine cube of theta. For the solving, we will have sine of theta times 1 minus 2 sine square of theta equal to 0. So we have the two factor equating each with 0. We will have sine of theta equal to 0, and in this case theta is equal to sine inverse of 0, which is equal to 0 angle. On the other side, we have 1 minus 2 sine square of theta is equal to 0, and sine square of theta is equal to 1 over 2, and sine of theta is equal to 1 over under root 2, and theta is equal to sine inverse of 1 over under root 2, and this one is equal to pi by 4. This is the angle in first quadrant, and other angle in the second quadrant can also be calculated, but it is given that the theta should be less than 0 and greater than pi by 2. So theta is equal to 0 is not in the given range, so we can ignore it. Not in range. Only the theta is equal to pi by 2 satisfy the given range. So theta is equal to the pi by 4. So we have the y coordinate is equal to 0, and we have the theta, which is pi by 4. We need to find the value of x coordinate. So x coordinate can be calculated by using this equation, which is x is equal to tangent of theta. So plugging theta is equal to pi by 4, we will have x is equal to 1. So we have the point which is 1 comma 0, which is the x coordinate and y coordinate, and also we have the theta, which is equal to pi by 4. Okay, these are the information we will use further. Now we need the slope of the normal, and slope of the normal is perpendicular to the slope of the tangent at the point. So first we find the slope of the tangent. And slope of the tangent is equal to the derivative at the point where the curve crosses the x-axis, and point is x, y, and theta. Okay, and dy over dx we calculated in part A, which is 6 cos to the power of 5 theta minus 5 cos cube of theta. Now plugging theta is equal to the pi by 4. So we will have 6 cos to the power of 5 pi by 4 minus 5 cos of cube of pi by 4. So we have the slope of the tangent is equal to 6 cos pi by 4 is 1 over under root 2 whole power 5 minus 5 to the time 1 over under root 2 the power of cube. For the solving, we will have 6 over 4 under root 2 minus 5 over 2 under root 2, and this one is equal to the 3 minus 5 over 2 under root 2, and this one is equal to negative 2 over 2 under root 2. So we have the slope of the tangent, which is equal to negative 1 over under root 2, and this is the slope perpendicular to the slope of the normal. So we can say that slope of the normal is perpendicular to the, this is the perpendicular sign, which is perpendicular to the slope of the tangent. So the product of the slope is equals to negative 1. Slope of normal times slope of the tangent, which is negative 1 over under root 2, and this one is equal to negative 1. So we have the slope of the normal, which is equal to under root 2. Now we have the slope, we have the point, which is x comma y, and this one is equal to 1 comma 0. So we can apply slope point form using slope point form. We have y minus y1 is equal to m times x minus x1. In this case, this one is x1 and this one is y1, which is 1 comma 0. So plugging, we will have y minus 0 is equal to slope of the normal, which is under root 2 times x minus x1, which is 1. So we will have under root 2 times x minus under root 2. So we have the equation of the normal, which is y is equal to under root 2x minus under root 2. So we have calculated the required equation, which is the slope of the, which is the equation of the normal.